there was a request to review half-wave and full-wave rectification, right? So we will do that first. Everyone else, if you want to review something in particular in here, I have very big suspicions that you have to review 11.1 as well. I'll review this first, look back and see if there's anything else highlighted and review that. If not, we'll go in a linear fashion, which in the topics I think are most important for you to review. So first thing we'll do is half-wave and full-wave rectification. So first of all, the topic is, actually let's put some lines on here so it makes it a little bit more easy for me to draw. So the topic is rectification. Right? Let's put it a little thicker. First, we're going to have half-wave. Rectification. And this is just using a diode. Right? So you have AC power source, but using this symbol. This is an AC, alternating current. And then you have a diode somewhere, right? And this goes to, well, whatever you're using electricity. And this is going to be your plug, your outlet, right? So in your outlet, you're going to connect it to something that uses energy in the form of resistance. We don't need to know what this is. You just need to know here, what is the voltage going to be from here to here, right? Well, if you draw this for half-wave, let's try it like so, with the vertical being the voltage and the horizontal being the time. Normally this would be a sine wave because it's AC, right? So let's draw what it would initially look like before you rectify it, so easier to see. So it looks like a sine wave. And it goes both sides. So this is the input due to the AC. Right? The output is going to be in red, which is one way. So output, it allows it to go one direction and then it cuts off. Allows it to go in one direction and then cuts off. Correct? So the output is this weird half wave. Okay, let's go to full wave rectification now. And we're going to go down and we're going to write down full wave. Let's write this all in caps. Full wave rectification. And you have, again, the AC current, right? We have connections, right? And we want to go to the output, right? This is out, right? This is the in, so like the plug. And we're going to have a diamond configuration. Like that. We call this diode bridge. Right? On this diode bridge, you're going to have diodes. And what direction do the diodes point to? Well, you have to point them to the out, right? So I'm going to draw a red line from here to here for the output, and the input is going to go here, jump this, and go here, right? So the diodes all have to be pointing to the out. So you have a diode here, and the direction this diode is towards the out. A diode here also is pointing towards the out. We have a diode here also pointing towards the out direction, and we have a diode here also pointing to the out direction, right? Diode bridge. Now what happens? Well, all of these are going to make the current go through this out. So if you draw the voltage and time, it's going to look like this. Right? Finally, the last part of chapter 11 was how do you make this better, right? And of course, if you remember, chapter 11 was all about capacitors, right? So what I have to do is you have to add a capacitor to this. So I'm going to draw right here a capacitor. And in this side, well, it's the out. So whatever you connect here is going to look like a resistor. So you draw a resistor in the out to the in. Okay, so let's look at how the charges move, right? Basically, the voltage is going to go up to the peak, right? So this means a current is flowing through here. Part of it goes here and charges the capacitor, right? And the other part just flows past and goes here and is used as energy. So it goes to the peak. Now, in the second half, the voltage drops. So the voltage is dropping here, right? So what is happening? The current is decreasing, right? So as it decreases, the capacitor has a higher voltage than the rest of the circuit, right? So it's going to push its own current back through here. And what this does is it's going to increase the voltage from this peak all the way to here. And erase this part. Correct? And it's going to do it again. When it starts to go up, when the voltage starts to go up again, now it's able to recharge. It's not going to flow out, it's going to flow into the capacitor again. It's going to go in. And it's going to go as well in this direction. So it charges, goes back up. When the voltage goes down, again, the charge stored in the capacitor moves out and bridges this gap. So in the end, by using a capacitor, we're able to make the voltage pretty much a straight line. up, down, like this. Okay, so about this, will you ever be asked to actually try this and do math on this? And the answer is no. You have to be able to draw it. You have to be able to know where to connect a capacitor. So this capacitor has a particular position it has to be connected to, right? And that's it. Okay, so this is half wave and full wave rectification. Full wave rectification has one, no capacitors, and the second type has a capacitor before the output, right?